Hi there, math lovers, and welcome to another video of the series Math Olympiad Training Problems of 2025. Today we have selected a problem with polynomials. The request of the problem is quite easy, but I think that it is a quite instructive problem for students who compete at high school Math Olympiad competitions. So, the request of the problem is, does there exist a polynomial p of x with integer coefficients such that p of 2 is equal to 4 and p of 6 is equal to 6? If you have any idea how to solve this problem, I would be glad to see it shared in our comments. If not, let's take a look together at a possible solution for this problem. Again, we rephrase the request of the problem because we are asked to find if there exists a polynomial p of x with integer coefficients such that p of 2, so the value of polynomial for x equal to 2 is equal to 4, and the value of polynomial for x equal to 6 is equal to 6. Now, in order to solve this problem, we will suppose that the given polynomial is of the traditional form, where p of x is equal to an times x in the power n plus an minus 1 times x in the power n minus 1 up to a1 times x plus a0, where all, as the request of the problem gives us, all the coefficients an minus 1, an minus 2 up to a1 and a0 are integer coefficients. Now, let's suppose that x takes a value equal to m. We will have that p of m, so the value of the polynomial for x equal to m, is equal to an times m in the power n plus an minus 1 times m in the power n minus 1 up to a1 times m plus a0. While for another value of x, let's suppose x equal to p, we will have that the value of the polynomial for x equal to p will be an times p in the power n plus n minus 1 times p in the power n minus 1 up to a1 times p plus a0. Now, if we make the difference of these two values of the polynomial, we'll have that p of m minus p of p is equal to, we will factorize an times m in the power n minus p in the power n plus n minus 1 is again factorized times m in the power n minus 1 minus p in the power n minus 1 up to a1 is factorized times m minus p, and the two a0s will simplify because the difference of them will be 0. So we see from this expression over here that if m and p are two values of the polynomial, then pm minus p of p, which is the expression over here, is divisible by m minus p, because all these factors of the right hand side can be factorized by m minus p, because m minus p is always, let's say, a factor of these equation. So m to the n minus p to the n, m to the power n minus 1 minus p to the power n minus 1 up to m minus p. So we can factorize, and the right hand side will be an integer number, and the division p of m minus p of p divided by m minus p will also be an integer. Now, for the request of our problem, we have that m is equal to 6 and p is equal to 2. M minus p is equal to 4, while p of m is equal with p of 6, which is 6 by the request of the problem, and p of p is equal to p of 2, which is equal to 4. But we see that the difference of p of 6 minus p of 2 is equal to 6 minus 4 is equal to 2, while the difference between m and p is equal to 4. But we see that this number over here is not divisible by this number over here, because 2 is not divisible by 4. This is a contradiction. So this means we can finally say that such a polynomial with integer coefficients such that p of 2 is equal to 4 and p of 6 is equal to 6 does not exist, because if it existed, P of 6 minus P of 2 should be divisible by 6 minus 2. But 6 minus 4, which is equal to 2, does not divide 6 minus 2, which is equal to 4. So this is the solution of this problem. Please let me know if you have any alternative solution in the comments. Thank you for your time and see you on our next videos. Bye.